Hello, welcome back to Sushi Live Noding. The other day I was showing you how we can do like kind of like array modifications using animation nodes. It's actually like basic examples, but the fall off and the way we can work with multiple objects using animation nodes mechanisms is it's really simple. I really like it actually, and now I try to do the same using Sverchok, and with Sverchok we kind of sometimes need to switch gear a little bit, but they are kind of similar, and in a way you can do this in many different ways. But we can try to do like a simple one first. Maybe if no one ever show you this, maybe some of you will never understand, but I'll show you what I have learned so far with Sverchok. If you want to animate multiple objects and how to think about how you're transforming objects in the scene. Well, okay, let's just get started. I'll save this as Sverchok matrix basics. So if you have like Suzanne in 3D view and you are thinking how can I move Suzanne, there are actually many ways to do it in Sverchok. In the past, Sverchok actually wasn't made to work with objects until Sverchok has this PPY data and then object ID. So whenever you find nodes that says object ID, that's actually nodes that can be dealing with objects directly. The nodes itself might look a little bit intimidating at first, but they're actually quite easy to use. If you are thinking like I want to do the same thing like I did using animation nodes, and I want to use like a matrix and things like that, you will be in for a surprise, because that's probably not how you do it in Sverchok, but you can kind of do that as well. So if you have like a matrix in and then you want to move this monkey, in the past actually we cannot actually do that. So if you want to, I'll show you real quick. So if I use objects in Sverchok and get the monkey, and then if we are using things like bmesh, viewer bmesh for example, and you plug in the monkey data and you plug in the matrix. Actually, I need to provide something with the matrix, maybe just a single location, and plug in the matrix. What you're gonna get is actually like a duplicate of the monkey. This is like a different objects. It's not the same objects anymore. So that's the first thing. And of course, the next thing you might realize is that if you plug in things like line, that's actually giving you a lot of points. This guy actually allows you to generate the monkey, but they're all different objects. They're not the same monkey, right? So that's the second thing. Of course, you can do a lot of funky, interesting stuff really quickly, like that. You actually can make array of objects very quickly in Sverchok, just simply by plugging this matrix matrix transformations. So that's the first to understand if you are using viewer bmesh. Now I'll get rid of all this monkey head. We're not gonna do it that way. If you actually want to move the original monkey, you need to use something like object ID set. So that's the secret. So I'll delete everything and just leave back with original Susan head. So if I want to move this guy, I can use this drop down, get Susan head, and then okay. By default, with object ID set, we have these delta locations. Delta location is of course like a special data block for Blender objects transformation. So delta transform is something that you can have. It's kind of like the default position of your objects, while keeping this location, rotations, and scales 0, 0, 0 for the animators. I think that's sort of how I could think of it. So yeah, delta location, delta rotation, and delta scale, you can think of it like the default value for an object before they're animated, because animators always like to have the default value. That's why to have location, rotation, scale, transform that's 0, 0, 0, it's like it's a good thing. Well, anyway, with Sverchok object ID set mk2, we actually have it by default is delta location, so that's gonna be the default value for our objects. That's something to keep in mind. And if we plug in matrix in, you will be in for a surprise as well, because it's not gonna work, because delta location is actually a vector value. Delta location, delta rotation, and delta scale, they are all like 3 values, and so you don't plug it in using the matrix. Instead, you use vector in, and that way you can sort of reposition the character. But remember, we are dealing with delta locations. You can, of course, edit the location using Sverchok. Just simply type in location there for the props. Okay, so that's how, if you want to actually transform the object itself instead of making duplicates in Sverchok. Slightly different kind of thinking, but who knows, in the future Sverchok might have special nodes that's actually dealing with transformations in a lot easier kind of way. But for now, this is how you actually do it. If you want to scale it, for example, you just type in, you type in scale there for the props of that object, and then you can scale it. And if you want to rotate, you guess it, you type in rotate, right? No, that's actually wrong. You have to look at it here, and then it says rotation Euler. So okay, rotation Euler. Now you can actually do the rotations in a Euler fashion, but sometimes you have quaternion and all kind of different rotation here. Keep that in mind as well. The thing about this object ID set is actually dynamic. It's very, very interesting. If you actually type in rotation Euler 0, this guy will actually only works for the x-axis. So I'll zero everything out again. See, that's only the x-axis. Very, very important. If I change this index into 1, it's gonna be working on the y-axis. But if you get rid of everything, you're working with a vector value. And you're working on all 3 axes. So that's very, very important. Now, what if you want to work with multiple objects? How do you do that? So I'll save this and then save as a new blend files. If you want to work with multiple objects, I'll show you how. This is one way you can do it, but there are many ways, of course. I'll simplify everything, and for now I'll just gonna deal with the scale of the objects. Let's say we have a bunch of monkey head. Just gonna randomize the rotation slightly to make it more interesting. So we have 5 monkey objects. How do we grab all of them? There are many ways to do it in Sverchok. You can group them, of course. Select all of them and then Control G and group them. And you can use objects in and select them by group and then get selections. And now Sverchok knows we want to work on these 5 objects, and simply plug in this guy into object ID set. And if you use vector in, you can kind of do the scaling and whatever transformation or whatever properties, attributes that you want to work in, you just type it in here. And you can type in like BPY, whatever. But for objects, we know that it has a scale properties that you can modify. So that's basically the basic idea. And you already know that you can type in anything. Like if you type in a random numbers and specify, okay, 5 different numbers, you're gonna get like a random value between this low and high, of course. Yeah, that's if that's not as interesting, you can actually do like a stagger kind of animations, just like what you did using animation nodes. If you are using the offset and the fall off, kind of similar, even though it's slightly different, but the effects is very similar. So it's you have two options there. I'm actually probably one of people here that's actually using Sverchok and animation nodes, both of add-on at the same time. Sometimes it's not. You can try to do that as well. It's not the easiest way, because they are working slightly differently. But if you learn both of them, you kind of have different, like a more understanding of what's going on. So we have 5 objects, and if you want to scale these objects from 0 to 1 using Sverchok, but not doing it at the same time, you can do that quite easily as well. But you need a couple of nodes. First of all, we probably gonna need frame info. This is gonna be a time. Okay, we can animate them using time or any kind of value, but time is the easiest. Okay, you plug in time into scale, and then over time the object's gonna scale until I don't know, like unlimited size. You don't want to do that. You want to use a map. So if you plug in the time there, and then you say, okay, over 30 frames, I want to make these objects to go from 0 to 1. This is how you might want to do it. So this is one way to do it. So the objects just stop when it reaches a value of 1, because you specify it using the map range. And okay, what if you want to stagger these operations, and what if you want to have that kind of neat effects like in animation nodes where you have like a bounce effect or elastic, or like a, you know, like settle, like overshoot and settle things, all kind of functions. You can do that using easing functions. Okay, so in Sverchok you get a lot more like component levels nodes, and it might be difficult, but once you understand it, this is like very powerful. So instead of frame going into instead of frame values passing through the map range and then going through scaling, we want to use the frame to create easing functions, and then to go through all these. First of all, for the easing function to work properly, you actually need to pipe in the value between 0 and 1. So we need to actually give it a map range. So that's the thing. And then now that we are sure the value is going to be between 0 and 1, we can pipe this into easing. And the nice thing is we have this kind of preview of functions of, let's say if we are using the like easing and kind of, I think this is the settle or the other way around. Okay, this is the overshoot and then settle. Overshoot and settle. It's a nice function that you can give, so so the animation doesn't go linearly. By default, it's of course like linear as well. Linear interpolation goes like this. It just goes from one value to another. It doesn't have any ease in or overshoot, whatever. Let's use back ease out for now, and we know that this is actually gonna work. I'll show you. Let's plug this result into this guy, and since we have an overshoot, we need to I think I need to give it a value between 0 to 2, and then new, min, and max between 0 and 1. I need to normalize the value as well, I think, in order for this to work properly. Okay, let's have a look. Hopefully this actually works. Yeah, it's actually working. You see the monkey? It's kind of growing, and then it's overshoot. The value goes over this value over 1, and then it settles until it reaches 1. If you want to see the actual value, you can look at it here. this is the value that actually goes into the XYZ scale of the object. So it starts from 0 and then it's overshooting. It's overshoot and then it settles. Now I might be wrong about the value because I didn't normalize it. I didn't normalize this value properly. I might need to increase this value or reduce it. I don't know. If I try, see, between 0 and 1 it doesn't quite work. If I give it like slightly bigger value, because this thing overshoot the value, you need to kind of adjust it until it's a little bit proper. Yeah, I don't know. I think I need to adjust both this value in order to make this works properly. So that's actually proper because it settles when the scale goes to 1, but it overshoots a little bit, see, between 0 and 1.5. Okay, so that's a mouthful. That's you might think, okay, why should I need to go through all this technical stuff? Because once you understand these concepts, you can animate 100 or 1,000 objects very easily. You can orchestrate them quite easily as well. Let's say here, everything is still animating at the same time, even though they have like a nice settle there, nice easing function happening. You might already know how to do this. If you actually use math here and then kind of offset the value of this frame info, you're gonna get like a stagger kind of effect. Let's say we have 5 objects here. I'll give a count of 5. Start with maybe -50 and stop at 1. Here I'm giving a minus value and kind of offsetting the time. And by plugging this into that guy, we actually have 5 different values now. And now by doing that, we have stagger effect. See, I'll just play back the whole thing now with a full screen. So first monkey, second, and the next, and the next. We are controlling all of this simply by using numbers, just math. Everything is just math underneath Sverchok. Of course, math with some magic of nodes and logic and codes, of course. But yeah, this is like 5 objects and then they're appearing one by one. If you want to go deeper, maybe I recommend you to start looking at sorting the objects or perhaps controlling the timing of this. More or less just like you will get the result that's similar to what animation nodes can do. In fact, if you're curious and really clever about it, you can use animation nodes value and then pass it into Sverchok. That's way whatever mechanism that animation nodes already provide to you using the FALLOFF can be simply piped into Sverchok quite easily. And that's probably something that I will show you in the next live noding. If not the next one, maybe the next in the near future. So yeah, yeah, this is how you might want to do it. If you want to stagger animation effects, you can actually randomize it as well. If you, instead of using this range float, you can use a random number and just give it a number between -100 and -50, and then plug this into the offset. Now they're kind of animating in more random fashion. They're not like one by one, but it's more like random, and then they're appearing. So this will work as well for multiple objects. At some point when you reach like thousands of objects, Blender might slow down and you might need to do the baking and stuff. That's kind of okay. But let's say you have like 10,000, let's say you have 10,000 objects and then you kind of merge it and join it into a single mesh, and then you want to animate each and every part of it. You can actually do that using Sverchok, and that can be quite interesting. A single object with 10,000 different parts and you want to animate each one of them. So that's a little bit more tricky, but the same concept here. Once you understand this basic one, you can do like a transformation animations very easily for any type of object, any type of mesh components. Yeah, so yeah, that's this live noding video might be a little bit complex, but if you have any question, feedbacks, suggestion you want to know, let me know in the comment section below. Thanks again for tuning in. I'll see you in the next video.